Local productions seen on Delta College Public Media are made possible with support from viewers like you. Thank you.
Hello, everyone. Welcome to Junia Doan's The Spark. I'm Junia Doan, and thank you for joining me. My guest today is Dr. Nancy Ruzycki. Nancy is the Director of Undergraduate Laboratories in the Department of Materials Science and Engineering at the Herbert Wertheim College of Engineering. Welcome, Nancy. Yes, I'm intrigued by a lab you teach called Sustainable Engineering and Design. Could you tell us about that? It sounds so interesting.
Back in 2015, we carved out some space in our curriculum to teach an additional laboratory to sophomore students, because we found in engineering, a lot of students drop out as sophomores because they don't see the relevancy of engineering to their lives. So we created a laboratory course that would introduce them to materials properties and principles, but at the same time cover aspects of sustainable engineering and sustainable engineering design and systems thinking. And so we piloted it in 2016. We had a grant from VentureWell, which is part of the Lemelson Foundation from MIT for entrepreneurship. So we built in entrepreneurship, engineering design, and sustainable engineering. So every year the students get a theme. And that theme is related to sustainability around the world and also related to something that deals with polymers, because we want to teach them something about polymers and materials properties. And so one year we did fast fashion, and we looked all about fast fashion and what the materials were made of and how we design the materials and how we can design them differently so that they're more sustainable. And then one year we did the plastic straw problem, and students looked straws versus alternative materials for straws to see which ones were really more sustainable. And then this year, we're looking at things that sorb. And things that sorb are things like feminine products, bandages, paper towels, chemical spill pads, diapers. And they're looking at what materials are used in those products, how they work, how they're made, how sustainable they are, and how we can possibly design them to become more sustainable. And we've also done food packaging, because food packaging waste is a huge problem. So the students learn all about the materials. They learn about how, as an engineer, we characterize and test those materials. And then they go through a design process where they do a life cycle assessment on the materials. And then they make a proposal to try to create a greener product.
Does sustainable mean reusable, or what does sustainable mean in each of those cases?
So sustainability can be viewed in different frameworks, but in general, sustainability is about using materials that are sort of circular in nature. Either we can recycle them and reuse them, or we can take them and take out some essential parts that could be reused somewhere else, or we're not depleting our resources by using these materials.
That's a challenge.
It is a challenge. When you think about things like your cell phone, right? Like we go through our cell phones every few years. There's a ton of critical metals that are found in our cell phones, and yet we do very little electronic recycling or recycling of our phone. And so they mostly get thrown away. Or they go to a third world country where small children have to, disassemble them for the little bits of metals in there. As an engineer, we challenge our students to say, how could I design a phone that's portable or disassemblable, where the metals could be easily recovered, or maybe I just need a new camera or a new chip. Can I pop that out and put a new one in? So how do we as engineers design better products so that they're more sustainable to begin with.
So there's so much to do made of plastics and like straws and other things like that. But also, plastics are used in catheters and I don't know where else. And I always thought it would be interesting to focus on what you can do alternately, but also keep what are life saving or useful anyway. What is your thought on that?
Yeah, I think that's a really important point, Junia, that, there are things that we consider essential. And how do we design them to really even better do what they do? For example, at the University of Florida, there was a professor who realized that a lot of people who are catheterized, especially for urine catheters, become infected. And so what they did is they figured out a way to pattern the inside of the catheter so that bacteria wouldn't grow or transmit into or out of a person. And so the catheter was less likely to infect a person that it was in. And that's a great example of engineering design. That's an essential piece. But when we have something like, like I go to buy my waffles, I think I'm going to be good. I buy organic waffles, and my organic waffles are wrapped in like 3 layers of plastic and a box.
Yes.
Like, really? Do we need that
Yeah.
much plastic? So we should be using things where we really need it and then lessen up maybe or redesign things that aren't necessary.
I thought things came in boxes for two reasons, but I'm saying it so that you could correct me or add to the discussion. One, it protects the product, and two, it was easier to pack if they were regular sizes, rather than put in some kind of bag and thrown in, although I notice more bags coming that have things in them.
Yeah, and that's true. And that was a big forward moving piece in manufacturing, right? Is how do we compartmentalize things so that we can put them all and move them quickly? And that's a fair use of packaging. But like, my waffles, if I open my box and there's waffles, great, right? But like now my waffles are individually wrapped and then wrapped in a bag and then in the box, and then the box is wrapped in plastic.
Yes.
Food need that much protection? Like, how far are they shipping it that my food needs that much protection? So those are some of the questions we have to ask ourselves. And maybe we could still have the plastic wrapping, but maybe it should be made out of, I don't know, mushroom plastic.
I'd never heard of mushroom plastic. Tell us about
Oh
it.
yes, you can make plastic out of mushrooms. You can make plastic out of carrots. There's a lot of vegetative products that make really nice plastics. Now it's not as simple or easy as just making plastics out of oil, but they sell awesome pleather, right? Like, who doesn't love pleather? They sell awesome pleather that's made out of pineapple fiber.
First of all, so many things I haven't heard of. If people like me want to know more, how would they know that? How would they even ask? And never mind the price differential.
We all want to be better stewards of the planet. And when we think about things like fast fashion, like especially my students are very interested in sustainability. But they also get greenwashed quite often. And so, for example,
What
when
does that
I
mean to be greenwashed?
so greenwashed is when a company purports to be environmentally friendly and they're doing something that's supposedly addressing waste or renewables or something, and then they're really kind of not quite telling you the whole story. For
Oh,
example, like when I played soccer, they bought us these fancy soccer jerseys, and they were supposed to be made out of recycled water bottles. But then when you looked into it, they were less than 10% recycled water bottle, and the rest was just polymer, just regular old polymer that you make, nylon or rayon or polyester or whatever. And only a very small part of it was water bottles. And yet they were selling these shirts as a sustainable alternative. And they really, really were not completely sustainable.
so the question I would have is, could they have done it 100% or 90, just structurally, to make it whatever it's supposed to feel like, or be cut up or sewed or what have you? Or could they not have made it without the, oh, I'm saying it backwards. Could they not have made it more than?
Yes. So if I take something like my shirt and I want to recycle it, although this is cotton, But if I had a polyester shirt and I wanted to recycle it, you generally downcycle it. You go down a cycle. So my shirt might turn into carpet. And then if I
Oh,
recycle carpet, carpet might turn into plastic bags. And after plastic bags, you're kind of lost. You can't really recover it. So some plastics can be downcycled. But in the case of water bottles, for example, people say, oh, we recycle water bottles. Well, we only recycle a small amount because as you process water bottles through after they've been molded and made and used, they lose some of their properties. So you always have to add virgin material or new material into the
oh,
mix. And so many products can't be 100% recycled, but many products can be downcycled. Now, as an example of that, that's kind of interesting is that Ford Motors out of Detroit, Ford Motors sells Mustangs and they have carbon fiber hoods and they make carbon fiber rims. And they actually buy their carbon fiber as waste from Boeing, and it's waste from Boeing making carbon fiber jets. And so Ford buys that waste product from um, Boeing, and then they use it to make their rims and wheels, and they get a benefit because they're buying carbon fiber cheaper. And then Boeing has a benefit because they sell their waste and it's not thrown in a landfill. So that's an example of kind of upcycling that's useful and good. And we could recycle a lot of our clothing that we throw away. There's just not enough of a market for it
right now, anyway.
right
You
now
know,
anyway, and that's a great opportunity for entrepreneurs, right? So thrifting is great, but like, how much stuff really gets thrifted, but versus the amount of clothing that gets thrown away. And the same thing with food packaging, right? And the same thing with all our little plastic straws and cups and spoons and things, right? So, you know, engineers should be thinking before these things go out on the market, what happens to them at the end of their life, and then how do we design products that have a useful end of life.
so I have another request for your design lab. There are plastic packaging for like a, a scissor or something like that. And I have such trouble cutting, breaking, twisting the clear plastic packaging. Now I know that's to protect the product from being stolen or used wrong, but I said that has to be designed by a strong man because no women of my strength, not very strong.
I think part of that is for theft, part of it is for shelf life and shipping. But certainly it was not designed by someone who thought about people opening them. And so, like, even with my mother, as she got older, she had trouble opening like cans because she couldn't bend her fingers well enough to pop, even if the can had a pop top, right? And so, how do we design products for people at different stages of life? But allow the product to be protected, but also allow the user to be able to actually open them and use them.
What appeals to students if you want to keep them in engineering? I like this idea of what is the problem? How can it be identified better or described better? What are you trying to do? What is the thought process you try to teach them to make problem solving not more routinized, but more helpful?
Yeah, that's a good question. There's two things. Like when we do design, we teach them engineering design thinking, and we use a model that's adopted from Stanford, and that's the Stanford Design Cycle. And we say the first thing you have to do is understand the problem, and we call that the empathy stage. And in the empathy stage, they should go out and talk to stakeholders. So, for example, we have student teams that are doing diapers for their things that sort. And so we say, well, you should go talk to parents. You should talk to mothers and fathers. You should talk to siblings. You should talk to, right, retailers. You should talk, right, like what is it that people want in a diaper and what are their needs? And, talk to people who buy organic diapers and people who buy the cheapest diapers on the market. So once they go through the empathize stage, then they go to the stakeholder analysis and they have to decide what do all these stakeholders need. And then they have to say, how does that product meet or not meet the stakeholders' needs? And how might the product be designed or redesigned to better meet their needs? And then they go to the engineering properties. So, what properties, what criteria does this have to have? Does it have to be low cost? Does it have to be strong in different directions? Does it have to have a temperature? Does it have to be biocompatible? Right? So, what are the engineering constraints on the product? And then you brainstorm and you design what you think, and you come up with a lot of designs. And then you present those designs to your stakeholders, and your stakeholders will give you feedback on those designs and say, yeah, I like that idea, or no, I don't like that idea. And we always have to take back what the stakeholders say. And then the students will then go back and redesign, go back to the stakeholders. And then they build a prototype. And then they have to take it back to the stakeholders to test their prototype. And then once they do that, they go back and refine. And then they go back to the stakeholders. So the stakeholders are always engaged, and that way we know we're designing for people in mind. Now, when we take that to a problem-solving process, we use something called failure analysis or root cause analysis or process mapping, where you say, what is the problem? And before you figure out where you think the answer is to the problem, you have to lay the problem out in all its stages and its processes. And you examine each stage of it, and you say, at what point does this break down? So when does it not work the way I intended it to work? And then this is just the step I focus on. Because sometimes people will look too broadly at a problem, or they'll look too narrowly at a problem, and they won't see all the pieces and how they fit together in order to be able to design a solution. So we kind of teach our students to be more big picture to small picture, or small picture to big picture, depending on the problem, so that they kind of understand their problems in context and design better solutions.
So what I'm thinking about with the diaper example is there's so much waste on what it's around the stomach and the hips and this and that. Couldn't that be thinned out in some way? And then I'm thinking for people who are cost conscious, and a social worker told me that they don't change the diaper when it's dirty. They wait till it's filled just to save money. And so maybe you have a stakeholder, a hidden stakeholder, so to speak, that needs at least acknowledgement or at least advice.
Yeah, and that's part of what people actually think about is how do they quickly move that wetness away from the baby so that you're not irritating the skin or creating opportunity for bacteria to grow, and then move it towards the outer part of the diaper. And, to address a cost conscious person or the person that doesn't change their diapers, they'll put more gel powder in, and the gel powder is what soaks up the water in the urine. But the problem is they put too much gel powder in because people aren't changing their babies enough. That diaper gets heavy and it breaks apart because how much water is a diaper supposed to soak up, right?
Yeah. I think it's great to be an engineer. I married an engineer. I'd never met one before. But their way of thinking, they're just problems to be solved, right? Whatever it is,
Yeah,
just
yeah, and I think artists sometimes think that way too. When an artist is, say, designing a picture or take a movie, you want to make a movie, you're thinking about how you're going to stage things and what things are important and how you create drama and action. So I think engineers have a particular way of focusing in on specific types of problem, but I think that kind of system thinking is also used by artists and writers and movie makers as well.
describe a system thinking for us.
So system thinking is a way that we build knowledge, and when we do system thinking, we're thinking about things in terms of four areas. So we think about it in terms of what are the parts and wholes. So
Okay.
when I think about, say, a diaper, I think, oh, okay, the whole is a diaper, but what are the parts of a diaper? So a diaper's got an inner liner, an outer liner, tabbies on the side. It's got like the stuff that sorbs in between. So what are the parts of holes? And then I say, what is it and what is it not? So a diaper is something to catch urine and waste. It is not a bathing suit. It is not underwear, right? So what it is, and sometimes what it's not, is equally important. And then we say, what is it related to? Well, it's related to underwear, but it's not underwear. It's related to bathing suits, but it's not a bathing suit, right? It's related to clothing, right? So we think about what its relationship is. And then we also think about perspective. And this goes back to what you were saying. We have to understand the perspective of a cost conscious consumer towards diapers. And we have to understand, like, the yuppie mom who wants to put like organic bamboo diapers on their kid versus somebody who's just happy to be able to afford diapers, right? And so as a designer, you have to consider all those pieces, and that's system thinking.
I had the occasion the other day here in town to meet the architect of the redo of Notre Dame with the 500 workers. And what he told me, he said, this is a gift for the world, for everybody. And I bring the best of myself to it. So when I draw something, I expect and want the fabricator, the worker, to do it exactly that way and not some other way or cutting corners. And he was able to, his translator said, he was able to bring that kind of spirit to the people. So while it was redone in 5 years, they started to talk about normally it would take 20 years. So the leadership on any of these things hasn't been discussed, but I think having a believable, admirable leader also helps, and that leader might be you in relationship to yourself when you answer all these questions.
Yeah, I think that's true. And I think that was a really nice story because having a vision is really important, but being able to actuate your vision into reality is even more important. And that can be done by a team or it can be done by a singular person.
Do you find you have the mind that automatically looks for alternates?
Yeah, I would say I do. And I think some people do. And I think other people are more linear. And I think there's room for all kinds of thinkers. We just have to try to know what our thinking is so we understand our own constraints.
Interesting. I'm waiting for new materials. I think we're going to live in a fabulous time as our invention, not that there aren't challenges, but the breakthroughs in medicine and technology and materials, I just, they're going to explode. I had cancer a while back, and I was joking with my Kant. I really am a great fan of his. Um, and I said, "Well, what's new in cancer?" He said, "You can't ask that. I have a certain, in this field of mine, there's so much new every day. I can't keep up with it." And I think that that may be true in lots of fields that are both enhancing and maybe threatening. But we live in times that couldn't have been done before. I listened to a NASA guy talk about some of the moonshots they're going to concentrate on. And I was just wondering, that we have the measurement and the computer power that we didn't have maybe a long time ago and couldn't do quickly whatever it is they need to do now. So I'm glad you're doing what you're doing because those students can do whether to do it for jobs and they stay in the field of engineering or design, they bring a different sensitivity just by having the exposure from each side. Or I'd like to think they do. I think problem.
Yeah, and they get back in touch and they do are doing fun and exciting things and they remember their classes. I mean, I think that's the best reward as a teacher and instructor is when the kids reach back out and they're like, "Oh, Dr. R, I remember your class and you taught us to think this way and I use it in my company and solve problems." And that's a great reward.
Yes, and for you too. What are the rewards of teaching?
I think teaching the next generation, but I actually want to go back to your point because I know we're running out of time, but I do think that you're right. We're living in a different time. And I think back to my great grandmother who lived through the turn of the century. And, when she saw the change in electricity and cars, the rise of automobiles and vaccines, right, and new medicines, it was probably much like what we're living through now, where every time we turn around, there's something new and something exciting and something replacing the old. And people could have turned away from that then, and yet they turned towards the future for better or worse and made it work. And I think we can do that now as well.
And it can bring out the best and the worst of us. So you have to decide your character early on and to deal hopefully with a high side in what you do in life. Well, I'm very grateful that we've had this conversation, and our audience will be grateful as well, because you introduced the ideas of measurement, evaluation, comparison, design, and the fact that always break things down, the most common, the simplest, so you can get details massaged, arranged differently, or at least the questions when you get there, and be mindful that other people may see it differently. So thank you for appearing. And what I say to my audience every time, please go out and do something kind for someone you know and someone you don't know, and repeat it every day going forward. Thank you for tuning in. I'll see you next time, everybody.
To contact Junia, send her an email at juniadonsthespark@gmail.com. For more information, program schedules, and news about future guests, go to www.juniadonthespark.com. Thank you for joining us. See you next time on Junia Doan's The Spark.
Local productions seen on Delta College Public Media are made possible with support from viewers like you. Thank you.